Hey guys, welcome back. So in this today's video, I'll be talking about two important topics after the basic gates, which are the half adder and the full adder. So what is a half adder? Half adder is basically a combinational circuit that will add two inputs which are A and B to produce an output which is sum and another output which is carry. So what is sum? Sum is basically it is the combination of XOR gate and carry is the combination of AND gate. So here we have two inputs, so 2 to the power of 2, four different combinations will be there. So 1 2 3 4, so we have four different combinations. So I have to write 0 to 3 combinations here. So for 0, you know how do we write 0? So we have 4 8 4 2 1, but for this we take only 4 to 1 because we have only 2 to the power of 2, which is 4. So for 0 everything will be 0, so we'll write 0. For 1 we have 1 at the last in the 4 to 1 configuration, so 1 will be here. Whereas for 2 we have 2 in the middle, so 2 1, so this will be 1, this will be 0. For 3 we will be making 2 1, so 2 plus 1 3, so 1 and 1 here. For sum we write A XOR B, so only when these two inputs are different, then the output will be 1. For carry, when both the inputs are I, then only the output will be 1. So that is the expression for carry, which is the AND gate. So how we make half adder? For sum we have A XOR B, for carry we have A and B, which is AND gate, and for this we have XOR gate. So that is the simple equation of half adder. Now full adder. What is a full adder? It is a combination where it adds 3 inputs and it produces 2 outputs. 3 inputs, so 2 to the power of 3, which is 8 different inputs we have. The first inputs are A and B, the third input is a carry, which is C in. The output we have main output as the sum and the secondary output as the C out. So whenever we produce a full adder, we write the combinations from 0 to 7. So for 0, 4 to 1, so in the all the 4 to 1 place it will be 0. For 1, 4 to 1, 1 will be here. For 4 to 1, 2 will be here. 4 to 1, so 2 plus 1 3, so 4 to 1, so only 1 will be here because it is place of 4, so this 2 will be 0. For 5, 4 to 1, this would be 0 because it is a place of 2, this is 1. So 4 plus 1 5 6 7. So what is sum? Sum is basically the XOR. 0 XOR 0 is 0, 0 XOR 0 is 0, so 0. 0 XOR 0 is 0, 0 XOR 1 is 1. 0 XOR 1 is 1, 1 XOR 0 is 1, so 1 here. 0 XOR 1 is 1, 1 XOR 1 is 0, so 0 here. 1 XOR 0 is 1, 1 XOR 0 is 1, 1 XOR 0 is 1, 1 XOR 1 is 0, so 0 here. 1 XOR 1 is 0, 0 XOR 0 is 0, so 0 here. 1 XOR 1 is 0, 0 XOR 1 is 1, so 1 here. So for carry what you have to do, you have to check the majority. If the majority in these three inputs, if majority is 1, then only the output will be 1, otherwise it would be 0. So in this case zeros are majority, in this case zeros are majority, so in this 2 0 is the output. Here again 0 is the majority, so 0 is the output. Here we have 2 ones, so 1 here as the output. Here again 0 as the majority, so 0. Here 1 as the majority, so 1 as the output. Here 1 as the majority, we have 2 ones here, so that's why output is 1. Here all majority is 1, so 1 is the output. So how is sum written? So sum is written as A XOR B XOR C. So A XOR B, so this is A XOR B XOR C in, so C in is here, so we have to take XOR again for this. So this is the equation for sum. Whereas for carry we have A and B. So first do the A and B, which is A and B here, and then do A XOR B. This is A XOR B, A XOR B. Take the A XOR B here and A XOR B combine with C in. So you had C in here, take that C in and place it here. Then you have A XOR B and C in. So for that AND we have. So this is the AND gate, and for this we have the AND gate already. So these two outputs will act as an input for the OR gate because we have OR at the middle. So this is the OR gate. So for OR gate we have this, and then we get the C out here, which is this equation. So that is how XOR full adder is written. So full adder is also written using half adders, two half adders. You can refer to this, how full adder is written using the half adders. It is also written using the NAND gates and NOR gates. So there are various implementations, but for now you can just check this basic one and this full adder using the half adders for your understanding. So we'll meet you in the next video. Till then, goodbye.